On this lesson, we will work on examining elements from a graph. We can examine the nodes and edges from a graph in Network X. We have four basic graph properties that facilitate this reporting. We have the nodes, edges, adjacencies, and degree. These are set-like views of the nodes, edges, the neighbors, which are here, the adjacencies of this graph, and finally the degrees of the nodes in a graph. Remember that the degree of a node is how many connections we have inside this node. So suppose we have here this graph where we add the node 1, we also add the nodes 2, 3, then here we add the edge that connects the vertices 1 and 2, and then we add here with a string all of the nodes that this word contains. So essentially, since we're using the function add nodes from, we are adding the node P, the node A, then we go again to P, but P already existed, so we don't do nothing, then we add E, and then finally we add R. Remember, if you use the function add node only, right, if you use this function with this argument, then you will only add one single node, the node paper. But if you use this function, add nodes from, you're adding all of the characters inside this word. So this is what we're going to do for this case, and also let's add an edge that connects the nodes 3 and P. So from this, we can draw this graph. You would just type here network S, draw network S, and here we pass the argument of the graph G. We can run. And as we can see, this is our graph, right? 1 is connected to 2 only, 3 is connected with P only, and then we have the rest of the nodes. So apart from visualizing this graph with the drawing, right, we can examine some elements of this graph. And now let's use these functions to examine the elements of the graph. So let's add now a new code window here. And here we just type list G nodes. Then this is going to display a list of all of the nodes. By default, this function gnodes returns a set in Python. Okay, all of these methods and properties here return set-like views. And with this, we are transforming this set to a list. So now let's run this. Very well, here we can see all of the nodes inside the graph G. We have 1, 2, 3, P, A, E, R, right? We can also visualize the edges. In the same way, we type list G edges, we run. We see here the edges that we have inside this graph. We only have 2, right? We have the edge that connects the vertices 1 and 2, and the edge that connects the nodes 3 and P. So another property here is the adjacencies. We can access the adjacencies of a given node with G, A, B, J, and then we need to pass an index, which is the node that we want to check all of its adjacencies. So for instance, if we define a list like this and we use the function avj, and here we pass the index 1, we'll see all of the nodes adjacent to 1. So now let's run this. And as we can see, 2 is the only node that is adjacent to 1, right? It is the only one. If here we add a new edge, add edge that connects 1 with 3, and we update this notebook. And so here, okay, if we run this again, what are we going to see? Well, we are going to see now 2 and 3, because now 3 is also connected with 1. Very simple, right? Finally, now let's use the property of the degree. If we just type here G degree, remember that the degree is a scalar number, right? A degree of a given node is how many connections this node has. And so here we don't need to use the construction of a list, because this is going to return only a single number, a scalar number. And here we can pass the index 1, for instance. Since 1 is connected with only 2 nodes, the degree of 1 is 2. As we can see here, the degree is 2. If we add now finally a new edge, imagine we add here the edge 1, 4. So we are also adding a new node 4. Okay, if we rerun this and we update, we have here that 1 is also connected with 4. Also 4 is included on the list of nodes, and 1, 4 on the list of edges. So here, when we run the adjacencies, we have here 3 connections, and so the degree of 1 is 3. Very well, with this we end this lesson on examining elements from a given graph. We remind the student that you can download this notebook and all of this code on the downloadable documents of this lesson.